Good day, everyone, and welcome to the Osprey Legacy Society webinar. At this time, all participants are in a listen-only mode. Later, you'll have the opportunity to ask questions during the question and answer session. You may register to ask a question at any time by pressing the star and 1 on your telephone keypad. Please note that this call may be recorded, and I will be standing by if you should need any assistance. It is now my pleasure to turn today's conference over to the Stewardship Officer for Planned Giving at EDF, Mo Pepin. Please go ahead.
Welcome, everyone, and thank you for joining us for this special Osprey Legacy Society webinar event. And thank you specifically to our Osprey Legacy Society members, those of you who have remembered EDF in your estate plans. If you're interested in learning more about becoming a member of the Osprey Legacy Society, you can reach us anytime toll-free at 1-877-677-7397 or legacy@edf.org, and we will be looking forward to hearing from you. We have a special program for you today on the topic of plastics, and we notably have record attendance for this event, which confirms that this is an important topic to all of us. So without further ado, it's my pleasure to introduce you to our presenter today. Lisa Moore is a senior scientist in EDF's Office of the Chief Scientist. Lisa began as a Low-K Fellow in the Climate and Air program with EDF after completing her PhD at Stanford University, where she studied the effects of climate change on ecosystems. She spent 3 years on the EDF climate team, explaining the causes and environmental effects of climate change and providing scientific advice related to domestic climate policy and international climate agreements. Lisa then joined the Office of the Chief Scientist 10 years ago here at EDF, where her main focus now is exploring emerging issues that may be relevant to EDF's work to make sure that we stay at the leading edge in all of our program areas. And one part of her role is organizing a Science Day symposium twice a year, which is the origin of the content that we will be covering today. And following Lisa's presentation, we'll be joined by EDF staff experts Doug Rader, Jenny Allen, and Jennifer McPartland for a Q&A. And now I'll turn it over to Lisa.
Hello, everyone. It's really nice to be speaking with you today, and I'd like to add my thanks for your generous support of EDF and welcome you to this call. Today, I'm going to present a condensed version of our most recent Science Day, and then, as Mo said, my colleagues and I look forward to answering your questions. But first, let me describe Science Day a little bit in general. This event is an opportunity for EDF to explore issues that may be relevant to our work. The goal is not to make strategic decisions, but instead we want to hear from leading thinkers and discuss the issue with them so that we can learn. Plastic pollution is a very hot topic that touches on a lot of our work. We wanted to learn more, so we chose it as the topic for last month's Science Day. For this recap today, first I'm going to explore what we learned about plastic pollution. Then I'll talk about some of the solutions that our guest speakers discussed. And I'll wrap up with the take-home messages that emerged. An important starting place for understanding the scale and complexity of this problem is to remember that plastic is not just one thing. To make plastic, you start with what are called polymer resins and fibers. The most common resins are abbreviated here. From left to right, we have linear low-density polyethylene, high-density polyethylene, polypropylene, polystyrene, polyvinyl chloride, polyethylene terephthalate, and polyurethane. There are other resins as well, and also another important starting material for plastic that isn't included here are polyester and acrylic fibers. Those are used for textiles. But plastic is used in a wide variety of other market sectors too. This table shows the percent of total plastic production for each of those resins and market sectors. But even this doesn't capture the diversity of materials because the resins and the fibers are just the starting materials, and that's something I'll come back to later. You can see that the sector that uses the most plastic by far is packaging, and so that's one reason that we focused on packaging later in Science Day about where there are possible interventions. But this table just shows percentages. How much plastic are we actually talking about? Since 1950, we have produced over 8 billion metric tons of plastic, and that number is projected to increase to 34 billion by 2050. only about 2 billion metric tons of the plastic we've produced is still being used. In fact, 40% of plastic products have a service life of less than 1 month. We've accumulated over 6 billion metric tons of plastic waste so far, and that is projected to nearly double by 2050. Of the waste we've generated so far, only 9% has been recycled. About 12% has been incinerated, and the rest has been discarded and is either accumulating in landfills or in the natural environment. Unfortunately, there is a lot of mismanaged plastic waste in the world. This map shows the mismanaged plastic in coastal countries, and the darker colors mean that there's more mismanaged plastic available to be washed into the ocean. And you can see a hot spot in South and Southeast Asia. This next map shows the same thing but with finer resolution. The blue circles show river mouths. The size of each circle shows how much plastic that river carries to the ocean every year. And a recent study estimated that in 2010, about 8 million metric tons of plastic waste entered the ocean from land. One of our speakers estimated that if you addressed plastic waste in just 5 countries, India, Indonesia, Vietnam, Thailand, and the Philippines, you would reduce plastic input to the ocean by 45%. But plastic is not just in our rivers, coasts, and oceans. It is everywhere that scientists have looked. For example, some farmers use plastic sheeting to prevent weed growth. At the end of a growing season, instead of collecting the plastic, they often plow it into the soil. Your fleece jacket sheds plastic microfibers to the water and to the air every time you wash and dry it. Marine animals often mistake plastic for food, which can be fatal. And scientists have even found plastic particles in polar ice cores. And although I haven't included a photo of it here, last year they found plastic particles in human waste. So what does this mean for the environment and human health? For the ecosystems question, we focused on marine systems since ocean plastic pollution has been studied the most. More specifically, we learned about a recent study of coral reefs in the Asia-Pacific region. Just last year, scientists published a study about the effects of plastic waste on coral reefs. They took measurements in 8 different reefs from Myanmar south through Thailand, Indonesia, and Australia. Those reefs are shown in the red squares here. They looked at almost 125,000 individual corals, and for each coral they recorded whether it had plastic on it and whether it showed signs of disease. This graph shows the likelihood of disease when corals did not have plastic on them. Each of the stacked blue boxes on the left shows data from one of the coral reefs, with the Myanmar reef at the top and the Australian reefs at the bottom. The axis at the bottom shows the likelihood of disease increasing as you move from left to right. You can see that all the blue boxes are all the way over to the left. The vertical red band shows the average among the reefs. And of the corals that did not have plastic on them, only 4% had signs of disease. This next graph shows the same thing but for corals with plastic on them. You can see that all the blue boxes have moved way over to the right. In fact, 85% of corals with plastic on them had signs of disease. And why is this? Well, first, plastic can injure corals and make them more vulnerable to disease. Debris that covers a coral can create conditions that favor disease microorganisms. And perhaps worst of all, plastic actually brings disease microorganisms with it. In fact, coral disease microorganisms are more likely to be found on plastic than in seawater. In addition, some corals were more likely to have plastic on them. The scientists classified coral colonies into 3 major categories. There are the relatively smooth, massive corals. Then there are the more sheet-like tabular corals. And finally, there are the branching corals. The tabular and the branching corals have more spiky bits sticking out that plastic can catch on. And so these corals are 8 times more likely to have plastic on them. That matters because these corals increase the structural complexity of reefs, which creates microhabitats for a wide diversity of other organisms, including many fishery species. So threats from plastic to reefs' structural complexity are threats to fisheries. The coral reef study focused on pieces of plastic that divers can see when they're surveying a reef. But plastic debris breaks down into smaller and smaller pieces over time, and now the ocean is full of microplastic particles like the ones shown here, and even smaller nanoparticles that we can't see. Microplastic particles have also been found in seafood. These pictures show 3 examples of commercial species that have plastic in them. In the case of the jack smelt on the left, the plastic was only in the fish's gut, which people don't eat. But the oysters and the bar-tail flathead had plastic particles in the fish and the oyster's tissue that people do eat. What does this mean for our health? We actually don't know yet how microplastics in our seafood might be affecting us, but we do know that plastics can harm human health via various chemical and biological components of concern and by causing physical damage. Primary components of concern are the chemicals that are found in the plastic itself. These include known and suspected carcinogens, endocrine disruptors, allergens, and other harmful chemicals. Some of the very building blocks of plastic are harmful. An example is BPA, which is used in the clear, hard plastics of water bottles and in resins that line canned foods. BPA is an endocrine disruptor that mimics estrogen, and it can interfere with brain and reproductive development. The plastic production process can also introduce impurities. For example, if you recycle a container that held pesticides, the residue on that plastic could be introduced into the new plastic product. After manufacturers make a basic polymer resin, they add plasticizers to soften the material. An example of that is DEHP, which is another endocrine disrupting compound that's associated with abnormal development of the male reproductive system early in life. Then, manufacturers add many different combinations of chemicals such as fire retardants, antimicrobials, and pigments. These give different plastics their various properties, but they are also cause for concern. For example, fire retardants can interfere with neurological development in infants and children, and cadmium, shown here, is a toxic heavy metal that's used as a pigment. Workers can be exposed to these chemicals during production, but consumers can also be exposed to these chemicals in many ways. For example, when chemicals in plastic packaging leach into food or into beverages, or perhaps if we ingest or inhale microplastic particles and fibers. Now, I want to emphasize that not every health problem I've mentioned is caused by exposure to chemicals in plastic, and not everyone who has been exposed to chemicals in plastic will have these health problems, but we know enough to be very concerned. Secondary components of concern are the hazardous chemicals and microorganisms that plastics pick up once they leave the factory. They do that because plastics act as really effective chemical sponges. They'll hold on to chemicals that were in a container, and then if they're discarded into the environment, they can pick up pollutants that are in the water, in the air, in the soil, and if those particles end up in our bodies, there's a concern that those pollutants could affect us. Like any solid object, plastic can also cause physical harm. For example, large items can block an airway or a digestive tract, but it turns out that by the very nature of their size, smaller particles are more hazardous, and the very smallest pieces, which are invisibly tiny nanoplastics, are likely to be the most hazardous of all because they can go deep into our bodies where they may cause irritation, inflammation, and ultimately cancer. Unfortunately, we know the least about these particles because they're very hard to study, and it turns out there's not much funding to do so. Even though we still have a lot to learn, the health expert who spoke to us at Science Day emphasized that we know more than enough to know that we need to stop using what he called failed chemistry. I know that all of this is alarming, but fortunately there are many things that we can do. A useful conceptual framework for identifying solutions is to think about this pipeline that plastic follows from the factory all the way to the ocean. There are many potential intervention points along the way, and I'm going to talk about the ones we covered at Science Day. One thing we can do is improve litter capture. Cleaning up plastic that is already in the ocean will be very difficult and probably impossible for micro and nanoplastics, but we can prevent further pollution. For example, since rivers are such important sources of plastic pollution to the ocean, they can be targets for collecting waste and preventing additional ocean pollution. As you can see from these photos, the methods can be low-tech and inexpensive. If we look further up the pipeline in our solutions framework, we can think about how to improve waste management infrastructure. In many places, particularly in developing regions such as South and Southeast Asia, a lot of plastic waste actually has potential economic value, but it's just not easy to capture. There may not be any infrastructure, or there could be local groups that do collect and recycle plastic, but they need capital to expand. For example, this is a company in India that collects industrial plastic scraps and post-consumer plastic waste and then sells it into the recycled materials market. They need capital to expand the materials that they collect and market. Here's another example. This is a recycling company outside Jakarta. They've been recycling PET plastic for some time, and they want to scale up and grow the product mix that they sell into the recycled packaging market, but they lack capital. Ultimately, getting waste management in South and Southeast Asia to the massive scale we need to address this problem will take billions of dollars. However, the institutional investors with that kind of capital are currently unwilling to allocate into this sector because first they want to see a track record of profitability and a robust pipeline of investment prospects. One of our speakers was the founder of Circulate Capital, which is an impact investment management firm that focuses on waste management opportunities in emerging markets in South and Southeast Asia. Circulate Capital wants to increase the number of investable opportunities and demonstrate that investment in the plastic waste management sector can provide attractive financial returns. Their founding investors include companies like Coca-Cola, Dow Chemical, PepsiCo, and 3M. These investors have committed over $100 million so far, and Circulate Capital is making their first investments right now. This will help fill what our speaker called the missing middle between the small amounts of startup funding that's available now and the billions of dollars of institutional investment capital that are ultimately needed. If we return to our solutions framework, another important step is redesigning products and using different materials. Some products may still need to be in some form of plastic, though, so in these cases, what are the alternatives to our current failed chemistry? We already have a lot of new materials, like bio-based and compostable plastics, but it's important to understand what these labels mean because they can be hard to understand or even misleading. Bio-based plastics are made from renewable materials like wood instead of petrochemicals. They are currently a tiny but growing part in the plastics market, but it's important to understand that they are not necessarily degradable, biodegradable, or compostable. Degradable plastics break down under specified environmental conditions, but they do so much more slowly than compostable materials. Biodegradable plastics are degradable plastics that are broken down via biological processes by microorganisms. And compostable plastics decompose into carbon dioxide, water, and inorganic compounds as quickly as any other green waste in industrial compost facilities, and they should leave no visually distinguishable or toxic residues behind. But a really key phrase here is under specified environmental conditions. That's important because these materials are designed, tested, and certified in the context of industrial waste management, which is absolutely nothing like the natural environment. This picture shows an industrial compost heap, and if you take a cross-section and measure the temperatures, you can see that it's really hot inside. In fact, the center of an industrial compost heap can reach up to 150 degrees Fahrenheit. That's important to know because this photo shows what happens to a compostable plastic lid inside the compost heap over 30 days. It decomposes just like it's designed to do. But look what happens if you put it on the surface of the compost heap, or for that matter, if you bury it in a field or drop it in the ocean. It doesn't break down at all. So it's important to remember that no matter what kind of plastic you have, litter is litter. If we return to the framework one last time, we can improve litter capture and global waste management, and we can use better materials, but we also need to fundamentally rethink how we use plastics so that we make and use far less of it in the first place. We didn't have a guest speaker who tackled this directly, but everyone who joined us agreed that it will require a systems approach that takes into consideration the ripple effects and trade-offs of different actions. In fact, this conceptual solutions framework looks linear, but in reality the solutions are going to be interlinked to each other and to other environmental and economic outcomes. That's why systems thinking will be so important. So what were the take-home messages from Science Day? First, this is an enormous and complicated problem with serious consequences for the environment and human health. Second, there is no single solution. As much as we'd like to have a silver bullet, we know that we need to change a lot of things and do some serious systems thinking. Third, there is still a lot that we need to know. This is a very new, extremely multidisciplinary topic, and it's moving very quickly. The scientific community needs to coordinate, they need to set priorities, and they need to standardize their research methods so that we can make more progress faster. And finally, every speaker gave us plenty of reasons for concern, but what surprised me was that every one of them also gave us reasons for hope. For example, it's already clear what some of the solutions need to be, and some of those solutions are already underway. Another important factor is that there is no one who is in favor of plastic pollution. Plastic pollution has what one of our speakers called an ick factor. It's obvious, it's tangible, and it's personal. That means there's great interest and engagement from every relevant stakeholder. As a result, all of our speakers felt like there's real potential to make a lot of progress quickly. That optimism is something that I carried with me from Science Day, and I hope that that's something that you'll take from this webinar today. So, condensing about 5 hours of material into 20 minutes leaves out quite a lot, but fortunately we have time to take your questions and dive into more details. Before we start that discussion, I'd like to introduce 3 colleagues who helped organize this symposium and who will be taking questions. First, we have Dr. Doug Rader, who is our Chief Ocean Scientist, and I'll let him say hello.
Hello, glad to be here.
We also have Ginny Allen, who is the Director of our Supply Chain Work in the EDF Business program.
Good afternoon.
And we have Jennifer McPartland, who is a Senior Health Scientist in our Environmental Health program.
Hello, everyone.
So we're looking forward to talking about this with you, and we're looking forward to your questions. Operator, could we have the first question, please?
As a reminder, if you'd like to ask a question, please press the star and 1 keys on your telephone keypad. We'll take our first question from Judith Weiss. Please go ahead. Your line is open.
You can hear me?
Yes.
Okay, good. In terms of changing the supply chain and changing the stuff that breaks down into microplastics, by far the most abundant type of microplastics are microfibers from clothing from washing machines. And there are connections that some of us, our environmental scientists, are making with material scientists and textile scientists to try to change the way that petroleum is turned into fabrics. And there seems to be some promising research. It's not, ready for being turned into your jackets or sweaters, but there is promising research to create textiles differently in such a way that they will shed much less. And I think that's a really important way to reduce the microfibers out in the environment, because they are by far the most abundant type of microplastics.
Thank you very much for that information and that comment. Yes, there are a lot of different things that scientists are looking into to make these products less likely to shed microfibers and to form microparticles. I know that that there are also some entrepreneurs designing different appliances and add-ons that you can use in laundry facilities to capture those microfibers when you're washing and drying plastics that can shed microfibers. I'm wondering, Jenny, maybe if you have any comments on work that we're doing or that you're aware of on designing new products like Ms. Weiss was describing?
Thanks, Lisa. It's a really good point, and one place where our team has been very active for a number of years is working with the Sustainable Apparel Coalition, and a lot of that work has focused more on chemicals and the health impacts of the additives being added to it. But I think this point about microplastics is a great one. I know I went out and bought a guppy bag to wash my synthetic things in the washing machine once I read about this. So hopefully groups like that will be tackling this issue. I don't think it's necessarily been on EDF's radar screen in our direct work, but some of our partners are looking into topics like this.
Am I still on the line here?
You are.
Hello? There's some of the things to put in the washing machine, like I don't know about the guppy bag, but there's something called the Coraball that was tested and only removed about 1/4 of the microfibers, so it wasn't all that effective. There is a kind of filter that one can attach to a washing machine that will in fact trap the vast majority, upward of 90% of the microfibers.
Thanks. That's great to know. Operator, could we move to the next question, please?
Yes, we'll take our next question from Casey Lush. Please go ahead. Your line is open.
Hi. I'm hoping you can talk a little bit more about any work that EDF is doing specifically related to plastics.
Thanks for that question. A great one. Even though we design Science Day to learn, we are doing some work that touches on this already, and I think Jenny is best suited to answer this question from the EDF plus business perspective. Jenny?
Thanks, and when I get done, if Doug and Jennifer have things to add, I'd welcome that as well. I'm sure many of you probably are aware that the EDF plus business work started with our original partnership with McDonald's almost 30 years ago, working on solid waste issues, and we did a lot of work with them to move away from the styrofoam clamshell packaging to the paper wrappers for sandwiches. So over the years, this has been an area where we've done work on and off. Probably what we're seeing right now with our partners like McDonald's, Walmart, and others that we talk to regularly, they're definitely feeling the pressure of ocean plastics in general, as it's been in the news a lot. And so right now, a lot of what we're doing is providing kind of high-level strategic advice and guidance to those partners as they're thinking through what actions they can take to address the issue and to do it in a way that is authentic and will have impact, and hopefully will really demonstrate leadership as well. And then I'll maybe let Doug and Jennifer speak to a little bit more specifics on the ocean and health side.
Great, thanks, Jenny. Doug here. So, in fact, I was a co-author on the science paper that Lisa reported on earlier, and we actually didn't fund that work on purpose. We didn't do it in the field on purpose. It came to us. We were working, as perhaps many of you know, on transforming wild fisheries to sustainability around the world, including in South and Southeast Asia, so in Myanmar, Indonesia, Philippines, and many other places. And in doing the reef surveys in those places to try to formulate sustainable fisheries problems, it became really apparent that plastics was a part of the equation that had to be recognized and dealt with. So I just bring that up as an example of the kind of integrated and opportunistic work we have been doing for a long time, and that we are trying now to catch up with the rapidly developing science as a primary determinant of where we go in our strategy. The real question is, what does this mean for the kinds of fisheries transformations that we have built in, factoring in the positive effects of fish, as everyone knows, is a positive part of your diet with omega-3 fatty acids and micronutrients and all kinds of great stuff, right? Well, what happens if they're, in addition to maybe the mercury that we knew about in big fish, what about now filter feedings like clams and oysters and mussels and coasts? Also filter feeding microplastics or even nanoplastics, and especially for those species where you eat them all, the guts and all, so exacerbating the exposure problem that Lisa mentioned. I would say that we are in the process of determining how to move forward with identifying the extent to which this brand new information and rapidly developing information requires us to take a somewhat different look at what we recommend about what people should eat.
This is Jennifer. Yeah, that was great, Doug. I think you captured it well. And I think the only thing that I'd add from the perspective of the health program, our whole raison d'etre is to reduce exposures to harmful substances. And unfortunately, there are many pathways of exposure, and there are many sources of harmful exposures, and plastics is one of those sort of pathways of exposure. And as Doug alluded to just a moment ago, the science is sort of still nascent in terms of what those potential suite of impacts could be, what levels and pathways of exposure are of concern, and what might that mean in terms of how we think about seafood and all of the benefits it has, as well as considerations around how to move forward in a sort of sustainable, both a sustainable way, but also in a health-conscious way.
Thank you. I hope that got at your question. We're definitely working on some things and really thinking deeply in other programs and across EDF. Operator, could we have the next question, please?
Of course. And as a reminder, to ask a question, please press the star and 1 keys on your telephone keypad. We'll take our next question from Taya Orgetta. Please go ahead. Your line is open.
Hi, yes. I wanted to ask, I saw a proposal for a startup which was talking about conversion of plastics via pyrolysis into energy sources. And so I just wanted to ask about whether you have heard of any sort of promising work in that area. Obviously, we want to take it out and not have so much as a feedstock for this, but is that an option that you know of?
Thank you for that question. Jenny, is there anything from EDF Plus Business on that? I can speak a little bit about that, but I think you're more on the ground.
I think the one thing I would say on that topic is it's definitely something that has come up as a question from some of our corporate partners. You know, is that a viable pathway? As part of a suite of solutions to the issue. So I think people are interested in it, but I'm not sure anyone feels like they've necessarily seen enough data in science yet to know how much weight they want to put behind it.
Thanks, Jenny. I will say that I'll add to that there is a lot of plastic waste, particularly in the developing world, that is simply burned because there's no other place to put it, which causes a lot of air pollution problems. So in some places, incineration with energy capture would definitely be an improvement, but you need to think about the toxic releases and the air pollution problems that could come from that. So it's one of the many, many things that people are looking at, and where there are trade-offs with those choices. Operator, could we have the next question, please?
We'll take our next question from Elizabeth Sasser. Please go ahead. Your line is open.
Yes. At Science Day, did you learn of any innovative policy work being done on this problem?
Great question. We actually did not have a speaker who was a policy expert, but I remember in one of the Q&A sessions, someone asked what was the fastest and best way to make progress. And he said, the capital is there and the science is coming along, but I'm sorry if you can hear, there are sirens outside my office window. I hope that there's not too much background noise here. he said that we absolutely need policy and political will to push some of the biggest the biggest changes that we need to see. But we did not discuss that in much detail because Science Day is it's focused on the science rather than the policy angles. I don't know if Ginny, Doug, or Jennifer, if you guys want to add on to that.
Doug here. So in application in different places, the degree to which those kinds of handles exist is very, very different. So, I think that EDF and all of our colleagues are really well placed to work on policy solutions, especially in the developed world. And as you move into the developing world, especially in the developing tropics, in many cases the policy framework and even the rule of law is not necessarily in place to make that happen, absent the right kind of economic drivers. And frankly, the systems are so diffuse that it gets difficult to imagine what it might be. I mean, some of our speakers suggested just ban the stuff, but then when you look at, across the board, but then when you look at the human uses of plastic in some of those places, it becomes harder to imagine what the transformed system looks like, and particularly places like Indonesia, the Philippines. Think of all those islands with little, if any, solid waste and or recycling infrastructure, and the fact that materials, whatever they are, health care, beauty, food, products, can only be afforded in the individual serving sizes distributed across tens of thousands of islands and hundreds of millions of people. And so you've got an unbelievably distributed problem, but where it may well be that completely innovative and outside-the-box ideas about how you move stuff like shampoo or ketchup or mustard en masse, or at least at the appropriate scale to communities or regions, the kind of systems thinking that Lisa was advocating may well have the biggest return. But for us, it's a wide open question about where the best leverage points are.
Thanks, Doug. And I would second Doug's point, and thank you for bringing it up, that the answers and the solutions and the importance of those different solutions are going to differ depending on the context, because plastic is used and managed or mismanaged in different ways in different places. So it is very complicated. Operator, could we have our next question, please?
Yes, we'll take our next question from Molly McPherson. Please go ahead. Your line is open.
Hi. So you touched on this in your presentation, kind of on how overwhelming and enormous the size of this problem is. And I was wondering if you or your team have any suggestions for how an individual on an individual level could best address the plastic problem?
Great question. I think that's something that has always been top of mind at EDF, but even more so now that we've been thinking about this and learning about plastic. Ginny, we were talking earlier today, and you mentioned some of this. Could you share some of your thoughts on this and what EDF Plus Business is seeing right now on this topic?
Sure. I think, unfortunately, some of it's not super exciting, but can have an impact. So I think, first and foremost, it's the more obvious, try to avoid plastic where you can, and in particular, single-use plastic items. Think about shopping bags, recent straw bans, plastic bottles, have a reusable water bottle. Those sorts of things do go a long way. A lot of the plastic, as Lisa covered in the overview, is coming from single-use items and packaging in particular, so where you can avoid those things, that will make a big dent. I think important, too, is understanding what can and can't be recycled. So, if you have the luxury of, a curbside pickup, or if you live in a place that actually has both trash and composting and recycling containers, make an effort to make sure you actually understand what can be recycled. There are a lot of issues with contamination of the waste streams that can prohibit things from being recycled. and not a lot of companies or municipalities do a great job of educating folks, and so unfortunately there's some burden on us to be well informed so that we can do our part to get things that can be recycled in the appropriate place, so that will happen. I think too, in many of the developing countries where we are seeing a lot of leakage of trash and plastic in particular making its way to the ocean. It seems pretty straightforward, probably from a U.S. perspective, but don't litter. A lot of trash that's just on the ground makes its ways into streams and rivers, and then eventually oceans, where it becomes a lot harder to collect. And then I would say as well, remember to vote with your pocketbook. The choices that you make are sending signals to companies who are trying to figure out what their responsibility is, how they continue to serve their customers well, while also making a profit. And so, communicate your needs and desires to the brands that you are loyal to. And I think people underestimate the power they have as consumers to get companies' attention and actually drive change at the product level. And I think Doug can probably speak to the seafood angle of this as well.
Yeah, that's right. Thanks, Jenny. But before I do, I would like to endorse your idea about the aggregate power of individuals working together. I think maybe the most dramatic example I know of now from my 31 years of work in this field with EDF is what is plastic straws. And I will just tell you, as a PhD marine scientist with lots and lots of years in the field, I'm not sure if any turtles ever died from plastic straws. But one viral video, people saying, I don't need a straw. How many people really need plastic straws? Some do, but not many. Has really created a viral movement around the planet that is nearly it's not single-handedly, it's multi-handedly eliminating that considerable use of materials. And so it's something really not to be underappreciated. But in answer to the other question, for me as an individual, I do want to know what is in the seafood that I eat and what my having chosen that seafood does in terms of the economics of sustainable production, and that's really the reason that we've invested with many others in building sustainable seafood cards. So I would personally make careful choices about what you buy, including your seafood, where it's from, how it's caught, and then as the information develops, EDF and our partners are going to be involved, both from Oceans and Health, in helping to make sure that new information about the relative health and sustainability benefits of different kinds of seafood are kept up to date.
Thanks, Jenny and Doug. Operator, could we have the next question, please?
Of course. And once again, if you would like to ask a question today, please press the star and 1 keys on your telephone keypad. And we'll take our next question from Maggie Sinkovics. Please go ahead. Your line is open.
Hi, can you talk a little bit more about what other organizations are doing in regards to plastics, and if you're working with any other groups?
Great question. Thank you. Jenny, can you tell us a little bit about what EDF plus Business has seen and who we might be working with on that?
Sure. As I mentioned earlier, I think a lot of our corporate partners and just companies in the consumer goods space are feeling the pressure from plastic ban straws and other initiatives, and so they're trying to come up with ways to address it. Many of you maybe have seen the recent launch of something called Loop, which is an initiative being run by TerraCycle, which is really looking at how can you start selling everyday consumer goods in reusable packaging. And so companies like Procter & Gamble, Unilever, Pepsi, Coke, Nestle are developing reusable packaging that gets kind of picked up and delivered at your house, much like a milkman used to function many years ago. And so I think that's an interesting pilot to see if there's traction. It's starting in France and some of the northeast of the U.S. So there are companies trying those sorts of things. I think there's been a lot of effort for a while to just increase the recyclability of products and packaging, as well as the recycled content embedded within those. one of the challenges that we've seen in that space is often there's a disconnect between the demand and supply, and companies who say they want more recycled content can't find it, and then you go to the municipalities who collect the waste streams and say no one wants to buy it. And so there are organizations like Closed Loop Partners who are trying to figure out what are those infrastructure gaps, if there are any, that are hindering more recycled content from getting back into the cycle of materials. You have groups like the Ellen MacArthur Foundation who are doing a lot around what they call the circular economy, so trying to figure out how do you close that loop and get materials back into circulation. So they've put out a report that's kind of a call to action that many companies are responding to. I think similarly, you're seeing, someone asked a question about policy earlier, you are seeing some cities and maybe states or counties doing different types of bans of plastic bags, places like Austin, Boston, Chicago. Others are toying with fees. And so I think there are a lot of, both on the company side and on the municipal side, trying to figure out what each of their roles are in this space. Additionally, too, there's a group that has, you may have seen it on your products and your packaging, and I know Walmart and others are trying to increase adoption of a how-to recycle label. So I mentioned earlier, doing a good job of recycling what can be recycled is important, and often it's not intuitive, and I am frequently frustrated that I don't even know, and I feel like I'm a fairly well-informed consumer. And so the How to Recycle label really breaks it down and has great graphics that, basically say, like, remove this part of the packaging, put the caps back on, this can be recycled, this can't. And so I think increased use of that by companies like Walmart and others will also help consumers have less confusion and frustration and feel like they can be part of the solution as well.
This is Jennifer. I just add one more thing to all of the great remarks that Jenny just shared. But another consideration that some organizations are focusing on is when we talk about recycling and the circular economy, we have to take into consideration the fact that there are harmful substances that are present in plastic. And so as we think about recycling plastic materials, we need to be thoughtful about also basically recirculating the harmful substances that are present in those in plastic products. And so there's a term that's called the clean circular economy, which is basically taking the fundamental sort of a basis of a circular economy, which is not letting things, trying to reduce the amount of things that are going into waste. But additionally, as you're thinking about circulating materials back into the economy, being mindful that you don't want to necessarily be circulating hazards back into the economy as well. And so there's a lot of discussion around how to do that, what technology is needed, what science is needed, what research is needed, so that we're not necessarily unintentionally bringing bad back in with the good.
And Doug here, if I could have 10 seconds. It would be remiss not to congratulate all the groups and institutions that are pouring money into what Lisa correctly described as the hardest part of this equation, which is recovering all that stuff that's loose out in the environment. And remember that only more or less half of it floats. The other half is on the ground in the bottom, going through completely different ways and very hard to recover. But just as one example, Ocean Conservancy is doing a great job trying to recover fishing gear, and though it seems like that would be especially part of the problem, when you look at the big gyres in the Central Pacific and Atlantic and Indian Ocean, a fair amount of that is actually derived from fishing gear. So there are lots of groups out there entrepreneurially looking to weigh in on the hardest part of this equation, which is what do you do with all the stuff that's already loose as you move to turn off the plastics fire hose.
Thanks, everybody, for those comments. Operator, could we have the next question, please?
Yes, we'll take our next question from Marilyn Judson. Please go ahead. Your line is open.
Hi. Can you hear me?
Yes.
Great. Yes, I worked for 18 years as an environmental compliance officer in an oil refinery here in Los Angeles, and I noticed that management occasionally was willing to go beyond the law and the regulations for public relations reasons. And one motivator might be to be able to claim that they were the first oil company to completely walk away from plastics production, or to cut way back, or to come up with a type of plastic that biodegrades more quickly. So I was just wanted to throw that out there, and remember that big oil responds to PR pressure.
They do, as well as much of industry. I wonder, Jenny, if you want to comment on that?
Well, I think it's spot on. It was somewhat fascinating. Doug spoke to this earlier, the plastic straw ban, and just kind of how that came to be, and watching corporate partners squirm, right, as they're in the crosshairs of being responsible, essentially, for, our consumer goods habits and the way that products are packaged and sold to us. And so I think PR is an incredibly powerful motivator, and hopefully many of our fellow NGO colleagues out there are taking good advantage of that to push companies to do a lot in this space to help actually play a role in addressing the problem.
Yeah, I'm reminded of BP making the claim, this is about 20 years ago, of being the only energy company, in quotes, that was investing in solar. And that served their purposes not at all, but to give them a really good message on television, a really good ad. It was this tiny, tiny investment. I don't know if they've even maintained it, but they made the most of it.
Thank you very much for that comment. Can we have the next question, please? I think we have time for one more question, but let's see how this one goes.
Take our next question from Maridel Gale. Please go ahead. Your line is open.
Hi. Hello. My question is probably directed to Doug. He was talking about the safety of seafood, and yesterday I spent the entire day at the Washington State Legislature listening to Willapa Bay, Grays Harbor oyster growers arguing to be able to spray the neurotoxin imidacloprid in their oyster beds to kill burrowing shrimp. They have been, this Willapa Bay, Grays Harbor in Washington says they supply 25% of the oysters in the country, and they have been spraying either carbaryl until that was finally banned because it was found to be a carcinogen, or imazamox, imazapyr, and now they want to force the state to allow them to spray imidacloprid. So I'm curious how, when you design these safe seafood and sustainable seafood cards, how you get information about things like that.
It's a really great question, and really clearly the biggest hazard is looking at these problems through a single lens, whether it's plastic or toxins or anything else. What we try to do generally is to factor all of the above in using available information streams, and when they aren't available, then to try to, meaning through the existing public monitoring systems, we look at mechanisms to use the private sector to amplify them. The best example is in the Gulf of Mexico, where everybody was really concerned after the BP oil disaster, irony, back in 2010, about the degree to which Gulf seafood from nearby, but also from far away in the Gulf, labeled Gulf, was safe to eat or not. And what we were able to do down there was to work with seafood suppliers and add on a completely incremental private-funded monitoring system that would not only additionally monitor what was there, but track fish individually with barcodes on the gill flaps of individual red snapper and also red groupers and tilefishes to show where they had been caught by whom, and to tie back to the incremental amounts. But I think what you suggested is a great example of the complexities here. So we have been just routinely, and I do know Willowpot Bay, and I've actually eaten oysters straight off the oyster reefs there. Of course, the irony is that those are introduced, Japanese oysters principally, but where there are, we've been basically uniformly saying that filter feeders like that are preferred, are really the best choices. So it's a good lesson, and we do need to open our minds to plastic and, for that matter, non-plastic based toxicants in making those recommendations. Thanks for the case.
Thanks very much for that question and your input there, Doug. Could we have our last question, please?
Yeah, our last question is a follow-up from Judith Weiss. Please go ahead. Your line is open.
Okay, thank you. It's not really a follow-up. It's a totally different question. In terms of the risk of absorbing contaminants from eating microplastics or eating fish that ate microplastics, it seems to me that the contaminants in microplastics or the contaminants that attach to microplastics are unlikely to come off during a few hours that food is in the intestine. I mean, particularly chemicals that are adsorbed. We talked about microplastics as sponges, and the chemicals in it. It seems to me there's really not much time for these things to desorb or to dissolve off the plastics into digestive system, and that the problems, if they do occur, would occur when the microplastics are physically blocking the intestine and therefore sitting there for a much longer time. And I'm just wondering what people think about this.
Sure, great question, and I think Jennifer is the one to answer this, and it goes to the size of the plastics and where they end up.
Yeah, thank you, Judith, for the question. It's a great one. I think one thing that came across, and there's so much to say about that question, and I realize that we're running out of time, but one thing that was very clear from the Science Day is that aspects of, let's say, risk to human health, such as sort of what the half-life or what the absorption or desorption rate might be of contaminants on plastics, are not sort of fully understood at this point, and that there needs to be sort of a concerted research effort to better understand, what the adsorption, distribution, metabolism, excretion processes look like once plastic is ingested. And I would say the other thing is that there are a variety of forms in which plastic may be ingested, and so while there's been a tremendous amount of emphasis on microplastics, there are even more nanoplastics. And one of the experts that we had at Science Day speaking to the health issue emphasized that nanoplastics may in fact be sort of among the highest risk-posing forms of plastics to human health, and yet it's the form of plastic that has been least researched, in part because of the challenges associated with analyzing nanomaterials like nanoplastics. So, but your point is definitely well taken, and I think it's this idea of what are not just the kind of physical chemical characteristics of plastics that may cause harm to health, but also taking into consideration sort of physiologically what we need to be mindful of as we think through what the concerns may or may not be.
Thanks, Jennifer, and thank you very much for that great question. I want to thank everybody for joining us today and for your great questions and comments. They've been really useful and give us even more to think about and to go and learn. This is obviously a really complicated topic, and there are a lot more ideas we could discuss, but unfortunately we're at the top of the hour. If you have any further questions about EDF or our work or this topic, please reach out to the EDF Planned Giving team. They're a valuable research and they'd be delighted to answer your questions. So finally, on behalf of all of my colleagues, I want to say again how grateful we are for your continued support. We couldn't do our work without you, and we feel so lucky to have you as part of the EDF family. Thank you very much.
This does conclude today's program. Thank you for your participation, and you may disconnect at any time.